Okay, so you've learned how to write rules for arithmetic sequence and rules for geometric sequence, and then all of a sudden they throw at you the idea that there's a recursive rule for sequences. What the what? Okay, let's look at that. So the rules that you've learned so far are called the explicit rules. And so you've learned that for an arithmetic sequence, that the nth term of that sequence can be found by taking the first term plus the number term you're looking for minus 1 times d, the difference between any two terms. And you've learned that for a geometric sequence, you can find the nth term of that sequence by taking the first term and multiplying it by the common ratio raised to the number term you're looking for minus 1. And so those are both called explicit rules. They allow you to find any given term of a sequence as long as you've got the first term and either the common difference or the common ratio. Now, the recursive rule defines a sequence of numbers in terms of the number that came before it. So in the instance of an arithmetic sequence, what that means is the a sub nth term, whatever term you're looking for, can be found by taking the a sub n minus 1 term. And what that means is that means the term before the term you're looking for. Okay, students get really tripped up by this a sub n minus 1 notation, but all that means is if you're looking for the fourth term, 4 minus 1, that's 3, you're going to use the third term, the one right before it. And then because it's arithmetic, and we know it's going up by the same common difference each time, you would take the term before it and add the common difference. And that is called a recursive rule. You are defining each term in terms of what you do to the term that came before it. So in a geometric, you would define your term by taking the term that came before it, the a sub n minus 1 term, and multiplying it by the common ratio. So now let's take a look at how we find the recursive rule. So let's say that's our sequence of numbers. First thing we're going to do always is we're going to check what's happening between them to determine if this is arithmetic or geometric. I always start by checking for arithmetic. It's just sort of easier. And lo and behold, we are adding 7 between each of these terms. Writing our recursive rule is going to be really easy. We simply say our a sub nth term is found by taking our a sub n minus 1 term and adding 7. Now, this is important. When you are writing a recursive definition, you must give a starting point. So this is not complete. You also have to include the following. My a sub 1 term is negative 2. And now I can go ahead and if I want to find my second term, I know that my a sub 2 term is equal to my a sub 2 minus 1. Well, 2 minus 1 is 1, and my a sub 1 term is negative 2, and so my a sub 2 term is negative 2 plus 7, or 5. And now that I have my a sub 2 term, I can find my a sub 3, and so on and so forth. Okay, let's take a look at it with geometric. If I take a look at division, negative 9 over 27, negative 1/3, and 3 over negative 9, negative 1/3, and negative 1/3 over 3, and so on and so forth. So to write my recursive rule, I'm going to remember I must start with my first term is 27. And now any term is defined as the term that came before it, and in this case, times negative 1/3. All right. Last, let's take a look at how we would go from the explicit rule to the recursive rule. So let's say we have our explicit rule, a sub n equals 24 minus 4n. All right, the first thing I need to do is I need to find my a sub 1 term. So my a sub 1 term, 24 minus 4 times 1, my a sub 1 term is 20. Let me find my a sub 2 term. My a sub 2 is 16. Let's find a sub 3. My a sub 3 is 12. I can see I am going down by negative 4 each time. That means that if this is my explicit rule, I'm always starting, remember, with a sub 1 equals 20 and then Any term can be found by taking the term before it and subtracting 4. And so that's my recursive rule for this explicit rule. Okay, and let's do it once for a geometric. So if this is my explicit rule, I'm going to find my first couple terms. So those are my first couple of terms, and I can see from 3 to 6, I'm multiplying by 2, and from 6 to 12, I'm multiplying by 2. And so now I can write my recursive rule, always starting with my definition. A sub 1 is 3, and so my recursive rule is a sub n equals a sub n minus 1 times 2. So when you're writing recursive, this first bit of a sub n equals a sub n minus 1, that is part of every single rule. Don't even think about it. Just write that on the page, then do your next stuff. All right, now, I would imagine that at this point, some of you are going, why in the world would I want a recursive rule? It's so much less effective. If I write my explicit rule, I can go ahead and find the 100th term without having to find terms 1 through 99 at first. Okay, that is true when your definition of things falls into arithmetic or geometric. However, sometimes we have sequences of numbers that do not fall into either of these categories, but it is still helpful to be able to write a rule for them. So for example, Jeremy has 20 pieces of Halloween candy. He eats 10% of his candy each day. He also earns 2 pieces of candy at the end of each day. So let's write a rule for this. So this is neither arithmetic nor geometric, but we can define it in terms of what happens the day before. So we always need to start with our initial term. So at the start of this, Jeremy has 20 pieces of Halloween candy. I'm going to call that our a sub 0 because at the end of day 1, he earns 2 pieces of candy. So if I then go ahead and say, so remember, we always start with a sub n equals a sub n minus 1 because we're saying, how do we affect the day before? Okay, well, we know he eats 10% of his candy. So how much does that leave him with? That's right, that leaves him with 90% of his candy. So I'm going to take 0.9 and multiply that by the candy he had the day before. And then he also earns 2 pieces of candy. So after he does that eating, he gains 2 more pieces of candy. And this rule will allow us to see how much candy he will have each day. And so this is where a recursive rule can be very helpful because it lets us define something that's outside of the realm of arithmetic or geometric. Okay, take a look at some of my other videos on this subject. Take a look at my Algebra 2 and Pre-Calculus playlists. Leave any questions you have in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.